Okay, so today we are going to talk about our inverse trig ratios. So when you think about inverse, what comes to mind? Reverse, inverse operations. So for example, what would be the inverse of adding? Okay, what about multiplying? Dividing. Okay, what about squaring? Okay, good. Okay, so these are inverse operations. Up until today, we've only really talked about inverse operations as operations, but we are going to start expanding our thinking about inverses to functions. Okay? So what you can think about, like, if I had a function f of x that took x and multiplied it by 3, the inverse of that function, we use -1 to show inverse. The inverse of that function would be either dividing by 3 or multiplying by 1/3. Okay, so it would undo the other function. So give me an x, like 2 or something. Okay? What happens when we're starting with 2. Okay, what happens when I multiply it by 3? Okay, now we're going to divide it by 3. We're back to what we started with, right? Didn't this function undo that one? Okay, so that's the kind of thinking that we need for any of this to make sense. So if we can think about our ratios not just as ratios, but as functions, where we feed the function an angle and we get out a ratio, then the inverse of that function, we will feed it a ratio and we will get back an angle. So it just does the opposite. Okay, so let's say that we do, let's try sine of 1/2. Can everybody try sine of 1/2 on the calculator? Make sure you're in, I'm sorry, not sine of 1/2, I'm tripping. Can you please try sine of 30 degrees? Make sure you're in degrees. Oh. Okay, so we're feeding it an angle of 30 degrees. And what do you get for the sine of 30 degrees? Okay, which we know as 1/2. 1/2. So that is the ratio of the opposite to the hypotenuse, correct? Okay. Now let's try something else. You see how on your calculator, let me make sure I'm in degrees. Nope. You see how above sine is the sine inverse? Okay. If I do inverse sine, and I feed this function the 1/2, 1 divided by 2, what angle do you think it's going to give me? 30 degrees. Boom. Okay. So if I feed this the ratio 1/2, it gives me back the 30-degree angle. If I do inverse sine of 1/2. Okay, so let's see how this works. We can go back and read those little paragraph blurby things after we've tried a couple, because I think they'll make more sense. So we're finding each angle measure, and we're rounding to the nearest tenth of a degree. So we're doing angle B. So with respect to angle B, which sides do we have? Well, we have the side that's opposite the right angle. That's always the hypotenuse. And then we have the side that's completely opposite to angle B. So this is our opposite side. So which of our functions relates opposite to hypotenuse? Sine. So we know that the sine of B is 3/15. Okay, now I'm going to rewrite this with a little bit of room in front of the 3/15. Sorry. So how do we undo a sine? Because my variable is inside of this sine function. I want to undo the sine to get my variable. I have to use the inverse to undo sine. So I'm going to take this whole thing and I'm doing inverse sine. So I have to do inverse sine to this side. Okay, the inverse sine undoes the sine and leaves the B alone. And this is what I put in the calculator. Make sure you're in degrees. So I'm doing inverse sine. What was it, 3/15? And I get 11 point, does it say hundredth? Nearest hundredth?
Tenth.
Nearest tenth, so 11.5 degrees. So the measure of angle B is 11.5 degrees. So if you want to, you can still set it up the same way and then just use the inverse to undo the ratio and get your angle back. All right, this time we're after angle Z. Okay, so the hypotenuse is always opposite our right angle. So we have the hypotenuse, and then we don't have the opposite this time, we have the adjacent. So which of our ratios compares adjacent and hypotenuse? Cosine. So we know that the cosine of Z is adjacent over hypotenuse, leave some room, 10/14. How do we undo cosine? How do we undo cosine? Inverse cosine. So whatever we do to the left, we have to do to the right. Okay, inverse cosine undoes cosine, leaving Z by itself. And that's what I put in the calculator. It takes this ratio and finds the angle that would give me that ratio. What was it, 10/14? I'm getting 44.4. So the measure of angle Z is 44.4 degrees. Easy enough? Okay. All right, let's do it with a word problem. A highway sign warns that a section of road ahead has a 7% grade. Percent means out of 100, right? So if I have 7%, that means 7 out of 100. Do you see where they got the opposite side and the adjacent? just like rise over run. Okay, that's how they got that picture. So if I didn't give you a picture, or if I gave you a picture and didn't have it labeled, you could take this percentage and change it into a fraction, and then you know your rise over run. Hint, hint, hint. You might have to do that. Okay, so we want the angle to the nearest degree that the road makes with the horizontal line. So that would be this angle A. So this is the hypotenuse, which we don't know anything about. And we know the opposite. We know the adjacent. Which of our ratios compares opposite and adjacent? Tangent. So we know that the tangent of angle A is, leave some room, 7 over 100. How do we undo tangent? Inverse tangent. Okay, if you get a really old textbook, they will call inverse tangent arctan. They'll call inverse cosine arc cosine. And they'll call inverse sine arc sine. So if you ever see that, that's what it means. Don't freak out. It just means inverse. Okay, so inverse tangent undoes tangent, leaving A by itself. And then we get inverse tangent of, well, we have to put that in the calculator and we'll get an answer. So 7 over 100. Inverse tangent, 7 divided by 100. Yeah, it says nearest degree, right? So 4 degrees. Measure of angle A is 4 degrees. Oh, does it say nearest hundredth? Oh, sorry, there's two conflicting directions. There's nearest degree and then nearest hundredth. So sorry about that. I was schizophrenic when I made this. Which one do you guys want to do? Oh, it is. Sorry. Couldn't make up my mind. Questions? Okay. Really quick, before we flip, if you see this pattern, you don't have to write this whole thing the whole time. Okay? Some of you, if you're fast, this was not me, but it will be some of you. You can just say, okay, well, A is going to be the inverse tangent of 7 over 100. I could never do this. I had to set it up each time and then do the inverse of both sides. But some of you will be able to do this and put it in your calculator, and it's one step. If that's you, great. If not, don't feel bad. I couldn't do it either, and I still have to think about it. Don't feel bad. It's more important that you understand where it comes from. Okay. Sometimes we are given some measurements to find the unknown angle and side measures of a triangle, and this is called solving a triangle. To solve a right triangle, you need to know either 2 side lengths or 1 side length and the measure of 1 acute angle. So that's a total of 3 pieces of information if you count the right angle, right? Because if it's a right triangle, you automatically get the right angle. Okay. Okay, so here we have 2 sides. So we have to find, let's call this X and Y and Z. Okay, I have a right triangle. How do I find the third side? Which ancient Greek theorem is going to come to my rescue? Pythag. So I know that x squared equals, x squared plus 6 squared equals 9 squared, right? So x squared equals 9 squared minus 6 squared. Everybody follow that? So 81 minus 36. I'm getting 45. So x squared is 45. What? Yeah, I haven't taken the square root yet. But yes. Sorry, my board's acting up. Okay, so I'm taking the square root. Okay, if this is going to be a length, do I need the negative answer? No. So my x is going to be the square root of 45. What is the biggest perfect square that's hiding in 45? 9 and what? 9 and 5. What's the square root of 9? 3. So this gives me 3 root 5. Okay, so that's one thing. Okay, we just have to find the other two things. Can someone shut our door? Okay. Which one do you want to find first? Y or Z? Z? All right. It's an odd choice, but we'll go with it. So if I'm looking at Z, I have obviously the hypotenuse, and then I have the opposite side, 6. So, we know that the sine of Z is 6 over 9. How do we undo sine? Inverse sine. Bam, bam, Z's alone. What is the inverse sine of 6 over 9? 41.8 degrees. Okay, be very careful. Your sides should not have degrees, but your angles obviously should have degrees. Okay, do you guys want to try with the shortcut on the last one? Let's be brave. Okay. So our last one, if we're looking at angle Y, we have the hypotenuse and not the opposite, but the adjacent. So which of our ratios compares adjacent to hypotenuse? Cosine. But I want the angle. I'm going to feed it a ratio and get back an angle. So I'm not going to use regular cosine. I'm going to use inverse cosine. So I'm going to say y equals inverse cosine of 6 over 9. What is it? Okay, so now that we did that, it was probably good practice. Couldn't I have just, don't these two have to add up to 90? If I have one of these angles, can I just subtract it from 90 and get the other one? but we could have gotten either of these first. So we have this, and we have this. Questions for me? Easy? All right. Okay, somebody tell me what the measure of angle C is. How did you get that?
I added 962 degrees. I was subtracted from 180.
There you go.
I was also able to do that, and I subtracted 62.5.
Yeah, so you used the fact that they had to be complementary, and you used the triangle sum theorem, and you're both right. Congratulations. All right, how do we find AB? Okay, well, the 10 is the hypotenuse. Oh, that was weird.
Which eliminates the
Okay. And AB, can I call that my x? That looks like my adjacent. So which of my ratios compares adjacent to hypotenuse? Cosine. So cosine of 62 degrees equals x over 10. So I can get x alone by multiplying both sides by 10. And this is what I put in the calculator, 10 cosine of 62. I'm getting, what does it say to round to? Nearest 10? 4.7? Okay. Now I want BC. I'm going to call that y. So that one is my opposite. So I'm going to use the y and the 10. Which of my ratios compares opposite to hypotenuse? Yeah. So sine of 62 degrees equals y over 10 multiply both sides by 10 . 8.8. Easy as pie. Okay, so tools for solving triangles. We have Pythag, we have our regular trig functions, and then now we also have inverse trig functions. So you got to be ready to use all of that. Yes? I could have, yeah. Yeah, once you have two sides, you can use Pythag. Okay. Here we go. Okay, Baldwin Street in Dunedin, New Zealand is the steepest street in the world. It has a grade of 38%. To the nearest tenth of degree, what angle does Baldwin Street make with a horizontal line? Okay, does this remind you of our 7% problem?
Yes.
Okay, so how do I turn 38% into a fraction? Good. Okay, can we focus please? So this is our rise, this is our run. So when I draw my picture, well, it says it's a steep street, so let me kind of make it steep. I wouldn't want to drive up that. Okay, where am I going to put the 38? On the vertical or the horizontal? Vertical. It's going to rise 38 for every 100 over. Okay, and it's asking me for the angle. So we're going to call this angle that the street makes with the horizontal, we're going to call him theta. That's just a Greek letter that we use as a variable a lot for angles. So the more you use it, the less scary it is. It's just a Greek X, like an X. All right, what do you think? Inverse of what? Tangent. We have opposite and we have adjacent. So we're going to use theta is equal to the inverse tangent of the ratio 38 over 100. So theta is approximately to the nearest tenth. .8 degrees. Easy enough, right? As long as you know how to do the picture, it's not any different than the other problems. All right, we've got a 16-foot ladder leaning against a brick wall. The ladder reaches a height of 15 feet on the wall. Find to the nearest tenth of a degree the angle the ladder makes with the wall. So are we finding the angle to the ground? Okay, so just make sure you're finding the correct angle. Go ahead and draw your picture. We usually put ladders on the ground. It says that the wall is vertical. Usually ladders have to lean against the wall. How long is the ladder? 16 feet. How high does it reach on the wall? 15 feet. Okay, so where is our theta? Up here or down here? If we're looking for the angle that the ladder makes with the wall, this is our theta. So we just have to read. Just got to be careful. Okay, so what is the 16? Hypotenuse. What is the 15? Adjacent. So which of our ratios compares adjacent to hypotenuse? Cosine. So are we trying to find a ratio or trying to use a ratio to find an angle? Okay, so we're going to use inverse cosine. So theta is the inverse cosine. Make sure you put them in the right order. It's still adjacent over hypotenuse. 15 over 16. What does it say to round to? 20.4? Yeah. When you're doing a whole bunch of inverse ones in a row, it's easy to set it up like this, but I find when I'm going back and forth between, like, am I feeding a ratio or am I feeding an angle, it helps me to just set it up from the start. You know what I mean? But you can do whatever works for you. All right, do you guys want to try this one on your own? All right, go ahead. Okay, so the 6.5 is our opposite The 8 is our hypotenuse. So we have sine information. So, do you want me to set it up the long way or go for the shortcut? Shortcut, okay, so theta equals the inverse sine of 6.5 over 8.
I got,
Go ahead.
I got 54.3.
Me too. Okay, so theta is about, what was it again? 54?
54.3. 54.3.
Yep. Yes.